Welcome to work problems, how to set them up and solve them. Work problems are very specific word problems that have to do with people completing a job. For instance, the basic idea behind a work problem is related to the rate someone works. As an example, if you know it takes Abby 2 hours to mow the lawn and it takes 1 hour and 20 minutes for Abby and Bob to mow the lawn together, how long does it take Bob to mow the lawn alone? These kinds of problems have a basic background that go with them, and it goes like this. The rate that each person works by themselves, and then you multiply it by the amount of time they work together, and then you get the amount of work that they do. So in our case, Abby's rate would be 1/2 for one lawn done in 2 hours, and Bob's rate would be 1/x for one lawn done in x hours. And then when we look at rate times time equaling the work done, since they both work for 1 1/3 hours, we would do the following. And knowing that 1 1/3 hours is the same as 4/3 of an hour, because it was 1 hour and 20 minutes, you do that conversion and you get it in terms of hours. And so you have 4/3 times 1/2 for the amount of work done by Abby, because she has a rate of 1 out of 2 hours. One job done in 2 hours, and she has the amount of time she's working is 4/3 of an hour. So we multiply that together to get the work done by Abby. And similarly, we do 4/3 times 1/x for the amount of work done by Bob. And since one job was done, we add these together and get the sum of 2/3, because when I simplified 4/3 times 1/2, the 4 is going to cancel with the 2, or you'd end up with 4/6, which reduces to 2/3. And then you multiply this across, you get 4/3x. So 2/3 plus 4/3x equals 1 is now the equation that we have to solve. And so to solve the equation, we might want to first get a common denominator. So I wrote 2x/3x plus 4/3x is equal to 1. And then I decided to multiply both sides by 3x, and I got 2x plus 4 equals 3x. And when I subtracted 2x from both sides, I would get x equals 4. So I know that it would take Bob 4 hours to complete the job alone. In summary, you find the rate of the work the person would complete all by themselves. You multiply that by the amount of time that they are allowed to work, and you add all of these values together to get one job done. Occasionally, work being done is against the job, so you subtract. Think of filling a pool while the drain is open. If the water is going in faster than out, the pool will fill, but the rate that the water is going in times the amount of time it's left going, minus the rate that the water is going out times the time it's left open, would give you the one job done.